Hi everyone, today's lesson is lesson 15, a synthesis of representations of equivalent ratio collections. Lots of big words. Synthesis just tells us we're going to be putting all of those ideas that we've learned together. Representations, we've got ratio tables, double number lines. Now we learned how to put all of that into a coordinate graph. So we're just going to be practicing that today. Make sure we understand that so you're ready for your quiz tomorrow. Oh, I said it. There's a quiz tomorrow. Okay, here we go. Exploratory challenge. At the end of this morning's news segment, the local television station highlighted area pets that need to be adopted. The station posted a specific website on the screen for viewers to find more information on the pets shown and the adoption process. The station producer checked the website 2 hours. Oh, there's a number hidden in words. We've got 2 hours after the end of the broadcast and saw that the website had 24 views. Can we make that into a ratio? Of course, Miss Haley, right? Okay, so we've got 2 to 24. So we're talking hours and views. 1 hour after that, okay, so we've got 1 hour after that, the website had 36 views. All right, they're trying to confuse you because it looks like it's 1 to 36, right? But it's not, because it's telling you 1 hour after that. So what's 1 hour after 2? 3, that's right. So 1 hour after 2 would be a ratio of 3 to 36. All right, so now what does it want us to do with this information? Let's take a look. It says create a table to determine how many views the website probably had 1 hour after the end of the broadcast, based upon how many views it had 2 and 3 hours after the end of the broadcast. So if we put that into a ratio table, we'll be able to figure that out pretty quickly. Using this relationship, predict how many views the website will have 4, 5, and 6 hours after the end of the broadcast. Okay, so it sounds like we're just going to be stretching our ratio table from 1 to 6, right? Let's create a ratio table here. We always label the top of our table so we know that the number, the first one is hours, and the second one is views, right? So we've got hours and views. This is how many times people looked at their website each hour, okay? So we can begin with, with 1, right? Because it wants to know 1 hour at the end of the broadcast. So we're going to try to figure out how many 1 is. But to do that, we're going to use what we know. We know that in 2 hours, there were 24 views. In 3 hours, there were 36 views. And then it wants us to find 4, 5, and 6. Right? So we can do that because we now know how a ratio table is created, right? We can look down and see what they added, or we can look across and see what they multiplied. How do we get from 2 to 24? Well, if we're not sure, we can take 24 and divide by 2, just like you did on your IXL last week. So we've got 2 goes into 2 1 time, 2 goes into 4 2 times. So it looks like we're multiplying by 12. Well, if we multiply 2 times 12, we've got to multiply 3 times 12. Is that true? 12 times 3 is 36, of course. So it looks like we're going to be multiplying everything times 12. Okay, so the question said 1 hour at the end of the broadcast. They want us to determine how many views there were. Well, we know that 1 times 12 is 12. Okay, so then 4 times 12 is 48. 5 times 12 is 60, and 6 times 12 is 72. Notice you could have just added 12 each time going down, right? Because it's the same as multiplying, just every time we're adding 12 or we're multiplying 12. Okay, now it wants to know what is the constant number C that makes these ratios equivalent. When we made our equations the other day, I didn't talk about this, but basically what we were doing is taking that number that we're multiplying and we're putting it into our equation. That is the constant. Constant means number that doesn't change. I hope you're all writing this. If I write it, you write it. Number that doesn't change. Okay, so what number doesn't change in our ratio table? 12. Okay, so now we're going to take that and we're going to make an equation to represent the relationship between the number of views, V, the website received, and the number of hours after each morning's news broadcast. Okay, so we've got H here and we have V here. So we just have to make sure we use the number 12 and show the relationship. So if I start with H and I say H equals, we're going to make two equations. We're also going to go with V equals. Notice these are the opposite, right? We have H and we have V. So we just have to make this true. So if H is 1, like we see here, how are we going to use 12 and 12 to equal 1? So if we take 12 and 12, if we multiply 12 and 12, do we get 1? No. But if we divide 12 and 12, do we get 1? Yes. So now think back to lesson, I believe it was 11. We used 1/12 times, in this case, V, right? Because it's 1 equals 1/12 times 12. We have 1 times 12 is 12, 12 times 1 is 12, 12 divided by 12 is 1. So is it true? Sure is. Okay, now let's go to the next side. Now we have V for views, and we need to see how do we make that into, or how do we get from V to hours? Again, we have to use 12 because that's the C, the constant. We have to use 12. So do we multiply or do we divide? Well, on this side we used 1/12, which means on this side we're just going to use 12, or we're going to just multiply. So dividing, multiplying, right? Is this true? Well, if V equals 12, like we see here, V equals 12, and then we have 12 times H, well, H is 1, is that true? 12 equals 12 times 1. It is. So these are our two equations. Okay, let's go on to exercise 3 here. So exercise 3, it says use the table created in exercise 1 to identify sets of ordered pairs that can be graphed. Okay, so I'm going to look back over here. Now remember from our lesson yesterday, the first column is the X, the second column is the Y. Our ordered pairs are always X, Y. So we're going to take 1 and 12, 2 and 24, 3 and 36, and so on to make our ordered pairs. Alright, so exercise 3, we have 1 and 12, 2 and 24, 3 and 36, 4 and 48. Where am I getting these from? The table, that's right. Just want to make sure you're clear on that. 5 and 60, and 6 and 72. I just remember them, but if you need to flip back and forth, it's there. All right, now we're going to take that and we're going to depict the relationship between hours and views on the coordinate plane. Label your axes. Ooh, and it says create a title. Do the points you plotted lie on a line? The answer is going to be yes, because you'll be able to take a ruler or a flat edge and you'll be able to run a line straight through them. If not, you did something wrong. Okay, so we've got our x-axis. So we look back over here. X-axis is hours, y-axis is views. So we're going to label our axis just like it says. So x-axis, hours, right? This is the x. This is the y. This is views. Writing sideways. Okay, so hours and views. And then we have all of our ordered pairs right here, ready for us to put onto our coordinate plane. Okay, now don't forget what I told you yesterday. Your numbers have to fall on a line. They need to be connected to a line. They don't go in between lines, like you can't put 1 here in the middle of these two. Do you see how it's in the middle of this line and this line? You can't do that. Okay. So let's do these correctly. So we've got 1. So 1 here, and then we have 2, 3, 4, 5, 6. I made that really small and really tight. You could stretch them out if you want and skip a line between each one. You're more than welcome to do that. Okay, then going this way, we have 12. I'm going to skip a line just to make it clearer. So skip a line. 36. Notice I'm putting this line that comes out. I want you guys to do that too, to show that it's connected to that line. This number 60 is connected to this line right here. Alright, and then we have 72 is connected to this line. Now all we have to do is match them up. So for 1, we go to 12, 2, we go to 24, 3 to 36, 4 goes up to 48, 5 to 60, and 6 to 72. Now if I take something flat like this and I run a line from 0 all the way through, they should all connect. Did it work? It sure did. It might be just a slight bit off. That's because my ruler wasn't very straight. Okay. Alright, so we've just put them on the graph. Coordinate plane. Graph, same thing. Okay, next. Predict how many views the website will have after 12 hours. Use at least 2 representations. Example, tape diagram, table, double number line, to justify your answer. Okay, so you can do this different ways. I like tables, so I'm going to make my table longer. We started at 1. Oops. Always label it. So we have hours and views. And what's it telling us to find? There's a number in words there. 12. So it wants our table to go up to 12. So if we have 1, we already know from the other page, 2, 3, 4, 5, 6. We could continue. 7, 8. We could also jump to 12 because we know what we need to multiply to get there, right? It's all times 12. So we can just fill these in from the other side. From our table, we know all of these already, no sense in doing extra work. Okay, so then we would add 12, which gives us 84. Add 12 gives us 96. Then I jumped, and it's times 12, right? If the first one's times 12 in your ratio table, it's always times 12. So we know that 12 times 12 is, that's right, 144. So how many views will the website have? 144 views. Alright, now it tells us to use 2 representations. I like the table. You could use the tape diagram, double number line. Double number line would be like this. Using a double number line. We have 0 and 0. We have hours and views. So this one you don't skip lines. So how I skipped from 8 to 12 here, you wouldn't do that on a double number line. It has to continue. So we would have, well, we could go 2, 4, 6, 8, 10, and 12, knowing that in between is the missing number, right? Alright, so at 2 it was 24, at 4 was 48, 6 was 72, 8 was 96. The only ones one we're missing is 10. Well, we know it's still times 12, right? We're multiplying by 12. So 10 times 12 is 120. And 12 times 12 is 144. Alright, are we good? Okay, so that was exercise 5. I still have a couple minutes left. For exercise 6, I want you guys to try this on your own and then come back and double check your answers. Remember to label and label. Fill in your graph. Alright, welcome back. Okay, so I'm just going to go through this really quick. It wants to know ratio, tablespoons of water, number of eggs. Tablespoons of water, number of eggs. So it filled this in for us, which is awesome. We know that for 2 tablespoons of water, we're going to use 3. So we're just going to go 2, 4, 6, 8, 10, 12, 3, 6, 9, 12, 15, 18, right? Whatever that first ratio is, we just keep doubling it and doubling it, just using that same number. Plus 3, plus 3, plus 3, plus 3, plus 3, right? Okay, so we've got our ratio table completed. We know that this actually makes an ordered pair, X and Y. So the bottom of our graph, and they didn't give us much room here, but would be number of eggs. And the Y-axis is, oh, I did that backwards. Oh, goodness. I hope you didn't make that same mistake on yours. X and Y, right? Here's the X. Here's the Y, and I'm trying to go fast so I have enough time to show you this. So water, eggs. All right, we can count by ones. 1, 2, 3, 4, 5, 6. Uh-oh, I'm not gonna have enough. Oh yeah, okay. 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18. All right, make sure your little line sticks out to show what number it's connected to. All right, so number of eggs on this side, tablespoons of water. So we're gonna go 2, 4, 6, 8, 10, and 12. That's a squishy little spot there. Okay, so for every 2 tablespoons of water, we have 3 eggs. 4, we have 6. 6, we have 9, 8, we have 12, 10, we have 15. Ooh, that's getting high. Make sure you follow your lines really well, all the way to the top. And then we take our little paper, and we draw our line, something straight. If you have a ruler, that's perfect, to show that it continues on and on. Okay, it says, what would you have to do the graph in order to find how many eggs would be needed if the recipe was larger and called for 16 teaspoons of water? Well, our graph would have to be longer, right? So we'd have to make our graph bigger. Stretch it out further. All right, so demonstrate on your graph. So we would have to go out. This would be 14 and 16, and then there's not enough space up at the top, but we could basically do it using our straight line here. As long as our line is perfectly straight, it should show us. So here's 16. 16 is going to go all the way up to here. It looks like this would be 19, 20, 21, 22, 23, 24. So it'd be 24 eggs. 24 eggs. All right, and then example 7. Oh, I'm out of time. So for your assignment, I want you to do numbers 1 through 5. You're using the graph on this side right here. Use this reproducible here to put your answers on. Make sure you read it carefully. It's got numbers, it's got words. Find all of those, and then show me when you're finished.